Okay, so to begin with, I got a TV theme for today. I don't know if anybody can name this TV show. No, no. Yeah, that's Urkel. All right. How about we do the math instead? So, the first one, it's got a common denominator already of 5. If that one isn't easy for you, then there's no hope for you today. 3 what? 3/5. Okay. So, this one, however, does not have a common denominator. And you've done this, but I need you to know exactly what you're doing because we're going to be doing these much more complicated. We're moving from the simple fractions to much more complicated. So, here you're multiplying by the other denominator. So 4 and 4. And why can I do that? Because I multiplied by 1. Why can I multiply this by 3 over 3? Because essentially I'm multiplying it by 1. You can multiply it by anything you want, but we wanted to have these come out the same, and it worked. They're both 12. I'm going to ask you to compare with the person that I pair you with today. These, of course, are easy, but it's going to get much harder. All right, so what we're doing is U2 kind of diagonal, U2 kind of diagonal. You're going to compare with Mr. D. U2, you are going with the person behind you. You are going to go over that way. Miss R, you're going to go with the person behind you. You're going to go with the person behind you. Person behind you, Mr. T, you done with this yet? Good. Person behind you is who you're going to compare it with. All right. Yes, sir. It is 11/12. 8 and 3 makes 11/12. Okay, moving on. These are multiplying fractions, which are even easier because you don't need a common denominator. Some people are talking over there. They're going to stop that. Multiply across the top, multiply across the bottom. 2 over 10. That reduces, of course. Now, I want to talk for just a second about reducing because there's a lot of reducing today. If it's a multiply problem on the top and on the bottom, which this is, then you can cancel stuff. There's one on the top and one on the bottom. If it's an add, you cannot cancel those 9s, for instance, because it's not a multiply problem. Now, could you do some reducing? Yes. What you should think of this on the one I just gave you here, 9 plus 3 over 9, is can you factor the top? Because if you can, then you could cancel something with the bottom. What factors out of 9 and 3? 3 does. So 3 comes out, and what do I have left? Once the 3 gets factored out of this and this, 3 plus 1. Okay, all over 9. And now that 9 could be factored. We don't often think of it that way, but this is factoring the 9, isn't it? Turning it into 2 factors. And if you can factor them, then you can cancel. Final answer is 4/3 on that. All right. This one, can you do some canceling here? Yeah, these are factors. They're already multiplied out. So now I can do some canceling within that. Yes. I know. Just listen. The reason that we do it this way is so that you can see such easy numbers that you can see it. Because when I do this, people go, well, I don't know if you can cancel it or not. I always try to show them using whole numbers, which they can totally relate to, and it is very easy to do the other way in your head. So I'm just trying to say that you can, if you can factor it, then you can cancel. You'll see what I'm talking about. We'll develop more. And of course, the easy way is to add it in your head and say, oh, well, that's the same as 9 plus 3 is 12, 12 over 9, and then reduce that. But can you factor something is the question that you got to keep asking yourself. All right, look at this one. It's already factors. If it's factors, then you can cancel. So this 9 can also be broken up into 3 times 3, and then you can cancel something. Final answer, 3/10. So it's not just about multiplying across the top and multiplying across the bottom. It's also about canceling. Okay, moving on to these two. Too much darny dance. Ugh, painful. All right, so anyway, this divided by sign should change to what? multiply. And if I change it to a multiply, the common mistake the answer is it doesn't matter which one you flip. False. You got to flip a certain one. Which one flips? Second one. 2/5 times 2 over 1. And if you think about it, it makes sense. Instead of dividing, we are going to change it to multiply. Well, you got to do something different then, because divide by a half is not the same as multiply by a half. So then you got to switch this. And if you wanted to think of it this way, dividing into halves is just like multiplying by 2. All right, this one. Do it quick. Check with your neighbor. See if you get the same thing. See if there's any reducing also. Several people have not compared yet. Okay. Change that to 3 over 2 and make it multiply. 21 over 22. Raise your hand if you had that one right. Okay, good. Next one is mixed numbers and impropers. Basically, fractions only play nice with other fractions. If I try to multiply 3 times 1/3, that doesn't work out near as nice as if I had 3 over 1 times 1 over 3. If you have fractions for both spots, it's a really good thing. All right, so let's make this into a mixed number. Well, that's kind of the opposite of that. You're taking something that would have worked beautifully as a fraction, and you're making it into 7 1/2. Do you know how to do that? You take this one divided by this one, and you see how many times it goes in there whole. It goes in there 7 times, plus there was 1 left over, 7 1/2. Sometimes I like to break it up this way, and sometimes this helps kids understand it better. This is the same as 14 over 2 plus 1 over 2. And that's why it's 7 1/2. Does that make sense to you? All right. So this next one is like what over what plus 1 over what. Make it into 2 fractions. I'd like to see if you can do that. Make it into 2 fractions that both are in 7. Let's try it. All right, Mr. D, what did you have? Plus 1 7 makes 8 7. Excellent. And that is 1, so therefore it's 1 and 7. Okay. The next part is where you change mixed into impropers. That times that plus that. 3 times 2 is 1 plus. 3 times 2 is 6 plus 1 is 7 1/2. Do that on the other one. Check your answer with the first I compared you with. What's 8 times 4? 32 plus 7. 39/8. Raise your hand if you had that one right. Okay, good. On to the next time. So this is on the top 20. We've done this one over and over and over and over and over again. So hopefully you're good at this. Do it. Check with the person I paired you with. Pause for a second. Okay, so here we go on this one. It's a divide problem, essentially. So instead of dividing, which is tough, you can change it to a multiply, and then flip this one. Make it 4/3. You should have said 1 times 4 is 4, 3 times 3 is 6, 4/6. Wrong. You got to reduce. Final answer, 2/3. Could I have done some canceling ahead of time? Probably. Oh, look at that, the 2 and the 4. The 4 could have factored into 2 and 2, and then this 2 and this 2 could have canceled, and I could have got 2/3 that way. All right, moving on. This is where it gets a little more abstract. Notice it's all variables. Okay, and next thing that's wrong is that your fraction doesn't have another fraction to play with. It's a whole number, A, and a fraction, B over C. So make it a fraction, and make it not be divided anymore, and then get yourself a final answer. Your answers will be like, AC over BD. Compare it first that I gave you today. Here we go. So we're dividing A over 1 divided by b over c, but instead, to be smarter, times by c over b. Final answer, a, c over b. Raise your hand if you had that one right. Okay, moving on. This one, again, a little more abstract. If you get how to get common denominators in the first place, use that same principle and multiply these both by something that's equal to 1, and then you get the common denominators, then end with an answer that has the common denominator on the bottom. It shouldn't be too tough to do. I don't want to just tell you, I want you to see if you can do it yourself. I'm going to pause while you try that. Okay, looks like I didn't get the answer on this one, so here's the answer for example 3. And we have, on that one, check to see if we could factor the top. And since we couldn't factor it, we couldn't cancel anything. Moving on to this one, and I'm encouraging my students to do the top part while I pause again. Okay, here we go. So on this one, you should have found a common denominator by going k, k, I. And why can I do that? Because I am multiplying by 1, basically. All right, so now it's kh plus ji over ki. The denominator doesn't get added, it stays the same. Next, you ask yourself, can I factor anything out of that top part? Nope, and therefore nothing can cancel. You're done. Now I have to multiply, or sorry, not multiply, yeah, well, this is divide by j over k, so I'm going to multiply by, and then that's k over j. Now, this is the important part here. Pay attention. Now, do you get that there are parentheses around the top that you may not even see of any complicated fraction? There is parentheses up there. So then, do you get that that k on the top is basically like it's been factored out? Because now this is a multiply problem, and this is one of the factors. Therefore, see how the k's been factored out of this? So therefore, it can cancel with this k down here, and this cancels that, and they don't both turn into 1. Final answer, k h plus j I all over j I, or I j, doesn't really matter. Now, if you had multiplied the k in with everything and then factored it back out again, you could do that too. But if you left that extra k in there, on the top and the bottom, it was not right. Very easy to forget that. Okay. Now we're getting to a part where I'd like to do this tag team. Okay, so your 2 rows, I want you guys, don't talk please, your 2 rows, I want you guys to be doing the top part right here. Okay, your 2 rows, I want you guys to figure out the bottom part. Everybody else, I want you to figure out what is going to be happening with the 2 chunks they figure out. Like, is this chunk divided by this chunk, or is it that chunk, that part, you know, this part and that part, the 2 parts they're figuring out. All right. Miss S, you are correct. Why don't you say what you said again? What should they be doing with this part, which the guys on the right side of the room are figuring out? That part goes here, and then you do what? Multiply by what the other part there, other guys are figuring out. Flipped. I like it. That'll go right here. All right. Guys that were figuring out the right-hand side. Can anybody verify that? Multiple people say it's 19/12. Excellent. Now we're timesing by instead of dividing, so then we have to flip this answer. Would you all agree that there's a 27 on top? But now that we flip it, there's going to be a 27 where? On the bottom. And the last thing is, what goes on the top? That's the hardest part. Those of you that had this part, what say you? And I hope you do a little reducing in there, too. Okay, the middle 2 rows. Have anybody got that done yet? All right, we're going to have to help them then, everybody. You guys on the left, you had the easy job. Try to simplify that and tell me what you think it is. I can tell you. What do you think? I think you're close, but not right. I think it's 3xy. Because this 12 changes into 4 times 3. The 4's cancel. 3 and an x and a y. Why is a y on top? Because it's like a y over 1. So 3xy. So 3xy goes here. All right, now canceling again. This is a big multiply problem. This times this, so these are factors. And this times that, so those are factors. So then I can cancel some. Who sees something that can cancel? Mr. V. The 12 and the 3, what do they both have in common? A 4. So I write this as a 4 times 3, and I write this as 1 times the 3. Then I cancel the 3. Boom. Awesome. Now I have a 19 on the top and a 4 and a 27 on the bottom. Is that a 27 or is that a 27? Okay, good. All right. So then 19xy all over 27 times 4, whatever that is. I remember it for now. 108. And the only way I could reduce that further is if 19 went into 108, because 19 is a prime number. But if 19 happened to go into 108, which it doesn't, I could have simplified it further, but there's my final answer. All right, now, this next part is where we are factoring. If you can factor, you should. You've heard me say that since the beginning of the year. You can factor, you should. So, you can factor, both on the top and the bottom. Factor them, and then things cancel, and you have a nice simple answer, like x plus 3 over x plus 5, that kind of thing. Now pause for a minute while you try that. Compare with the kids that I put you with for today. Okay, I agree. X plus 4 and x minus 4 on the bottom. And what'd you get on top? Well, how do you tell? It's the other way around, maybe. How do you know? The inside. Good. So you want this to be a plus 2 and a minus 4? All right. Plus 2 minus 4. Okay, then. Now that they're changed, I can do some canceling. Cancel, cancel. X plus 2 over x plus 4. Raise your hand if you had that one right. Okay, good. I think you've got the idea today, and your assignment is to do problems a lot like that. I'm going to pause for a second while we pull the assignment up. All right, so here we go. We have found the worksheet, and quiet, please. So let's do number 1 here. Oh, wait, it's the same basic thing as before. Factor the top, factor the bottom, see where things cancel. There's a lot of factoring, and this is just same kind of stuff that we did earlier in the year with the top 20. So if you stay caught up with that, then this should be easy for you. And I'm assigning 1 through 9 for today. Okay, that's it. Easy day. Now, some of you may not have already done the other thing that I assigned yesterday. I know some of you caught it and some of you didn't. You were going to be doing out of my I course, this due Monday also. It is under ACT Prep. Get into my I course, the one that's got my big eyeball in there. Yes, thank you, Tuesday, you're correct. It's this right here, TMT ACT Prep Level 2. That one. Okay? It's another practice on these. It's multiple choice, and you can use a calculator. And in theory, it's supposed to be timed to be 20 minutes long, so it shouldn't take you super long. And if you get these, we've done it. We practiced it once already. If you've gotten how to do them, this thing should probably take you 10 minutes. All depends on how focused you are. 10 whole minutes. And that's also due on Tuesday. All right, problems 1 through 9 of the other worksheets, plus this ACT Prep Level 2 version 2. And you can use your calculators on that. By the way, do you remember that GCF? There is no GCF on your calculator. It's called GCD. Because it's greatest common divisor. I know. And I wish they would have just said GCF, because I've never taught in a school where we use GCD. We always use GCF. So I think Texas Instruments goofed on that one, but they are not changing. So just find GCD on your calculator. Where's that? It's under catalog. The button on the lower left that's right above the 0 key is catalog. If you find GCD in there, it'll work. But by the way, since it's got 3 numbers, you'll want to do the GCD of these two. And then when you're done with that, the GCD of that, greatest common divisor, is 20, I think. Then you do the GCD of 20 and 100. And you put it in parentheses after it. So it says like GCD like this. And you put in 60 and 80 to start with. Then you get your answer for that, which will be 20. And you go, okay, so now I want the GCD of 20 and the other number, 100. Here's how to do GCD, just for a little reminder in case you've never used the calc before on there. Okay, and that's all the advice I have for you for today.